Here's question 5 on the AQA Use Maths decision paper. It's the non-pilot paper from June 13. It says the diagram shows the location of some houses in Palm Springs. The number on each edge shows the time in minutes to travel directly between pairs of houses, and we're told that Ron is outside house A when he receives an emergency call requiring him to drive to N by the quickest route. So we're starting at A and we're finishing at N. Part A says use Dijkstra's algorithm on the diagram to find the shortest travelling time from A to N. Show all temporary labels that state the corresponding route. So here's our diagram, and we want to start at A and we want to finish at N. Unfortunately, because of how my board's set up, this is going to be on its side, but I'm sure you can cope with it. So for Dijkstra's algorithm, we put a 0 where we start and put it in a box. And then we say, from there, where can I go? Well, I can go up to I, that's 5, or I can go to P, that's 10. And I've done everywhere I can go from A. So now I have a look at all my temporary labels. They're the labels that aren't in a box. Which is my smallest? Well, I've got 10 and 5. 5's my smallest, so I'm going to put it in a box. That makes I where I'm stood, and I'm having a look, where can I go from I? Well, I can go up to P. Now, because 5 add 4 is 9, that's smaller than my 10. So I'm going to cross out the 10, and I'm going to write 9 in. Where else can I go from I? Well, I can go to J, and that's 8. I have a look at my numbers, which is the smallest, so 8 is my smallest temporary label. Where can I go from J? Well, I can go up here, that's 9.6, or I can go across to K, that's 8.8. Now I've done everywhere I can go from J. I'll go back to having a look at all my temporary labels, which is the smallest, that's the 8.8, so I'm going to put it in a box. Now I'm going to see where I can go from K. Well, I can go up from K, that will take me to 9.5. 9.5 smaller than 9.6, so I'm going to write it in. I can go across to O. 8.8 add 1.6 is 10.4. Now I've done everywhere I can go from K. I have a look at my temporary labels again. I've got 9, 9.5 and 10. 9's my smallest, so I'm going to put it in a box. Now I can get to O in 9.8. So I'm going to cross out my 10.4 and write 9.8 because it's smaller. Where can I go now? Well, I've done everywhere I can go from P, so I need to go back to my temporary labels, which is my smallest, 9.5 or 9.8, or my 9.5 is the smallest. And now I need to see how far it is to N. I'm just going to smooth the board slightly so I can see the number. It's 1.4, so 9.5 add 1.4 is 10.9 to N. Now I've got an answer at N, but I don't know it's the smallest until it's in a box, so I need to keep on going. I'm going to have a look at my temporary labels. Well, I've got 10.9 and 9.8. 9.8 is the smallest. Where can I go from O? Well, I can go to N, and that takes me to 10.6. So I'm going to cross out 10.9 and write 10.6. I'm going to put the 10.6 in a box because it's the last place to go. It is really important when you do Dijkstra's algorithm that your boxes are by the vertices, not in the middle of the edges, and that you do show your crossings out. The final bit that we need to do is we need to give the route. Well, for that we're going to work backwards. From N, where did I come from? Well, I came down from O, so I'm going to write N at the end of my route. And then I'm going to write O as my next step. How did I get to O? Well, I got there from P. How did I get to P? Well, I got there from I. How did I get to I? Well, I got there from A. So I've found my route. It's A to I to P to O to N. And then part B says, by using the data sheet, find the total distance travelled by Ron that corresponds to the answer found in part A. So I need to go and have a look at my data sheet. So here's my data sheet, and my route was A to I to P to O to N. So all I need to do is I need to find the distance from A to I. Well, I look across and I say that's 6.8. I to P, well, I'm going to look across my I until I get to P, and that is 6. P to O, well, I'm going to look down P until I get to O, that's 1.2. I look down O for O to P, and that is also 1.2. So the sum I'm going to do is A to I is 6.8, I to P is 6, P to O is 1.2, and O to N is 1.2, and then I'm going to add them up to get my answer. And I get 15.2 kilometres. So I can write 15.2 kilometres into my answer, and I've finished.